force and laws of motion.
Okay.
Let's say. So how do we define force? See,
Abhay,
up to now, what we had done was we had done description of motion. Okay. So up to now we had done what is motion and how can we describe motion, right? In this chapter, we are going to do the laws of motion. That means now we are going to study under what conditions there will be motion and what type of motion will it be. So this is called as the laws of motion. Here we will see uh, rules and regulations which control motion, right? So in the laws of motion, when we move, the studies for every the science is like studying for the cause. Whatever we are seeing, we look for the cause. What is its cause? Okay, why it's happening? So if a motion is there, what are the different factors that are going to affect motion? This was what was being studied over here. So starting with the laws of motion, first of all, we come across science regarding Aristotle. So Aristotle was one of the great philosopher, and his thinking was that he had certain philosophies regarding motion. So according to Aristotle, he thought or his thinking was that all objects they have a tendency to stop, right? So since he observed all the objects around us, so he observed that it is a tendency of all objects to be in the state of rest. As we see that all the objects they want they come to a state of rest, right?
yes, sir.
Where if you even if you throw a ball, so certainly it comes to a rest. So whatever things we observe, he observed that whatever fast or however fast you can throw a ball, eventually it will come to rest. Okay. So this was Aristotle's thinking. We call it as Aristotle fallacy. Fallacy means it was not actually true. Okay. So according to him, it is tendency of all bodies to be in the state of rest. So this was Aristotle's fallacy. Why we call it fallacy? Because just after Aristotle, then Galileo started thinking over it. And Galileo started thinking that whenever any object is coming to a rest or coming to a stop, so it is coming to a stop because there is some force which is acting on it. Okay. And the force which is acting on it, it must be some opposing force which is always opposing the motion. And of course, it is dependent on the surface. So this was your Galileo's thought. Then he also coined about the term inertia. Okay, so Galileo, he performed certain experiments and then he informed that there is something called inertia, a tendency. So everyone was studying about the tendency, right? So Aristotle, he also thought that there is a tendency. Galileo also thought to be of a certain tendency of motion, which called as inertia. So according to Aristotle, what was it? That all the objects, they will eventually come to rest. Okay, I have not shared. Okay, everyone turn on your cameras, please. I forgot to share the screen. Let me share. So let's see. The laws of motion. Under the laws of motion, we will see about Aristotle fallacy. Okay, like so Aristotle was something whatever he observed in the nature, he pointed out the things from there. He tries to frame the laws from his observations. So since Aristotle has observed that all the things they come to rest, finally they come to rest. So therefore he concluded that it is a tendency of all the objects to be in the state of rest. Then Galileo performed certain experiments. And what was the result of the Galileo's experiment? He performed a fall experiment. Right? So first of all, what we are going to study in this chapter? Aman? Aman?
Yes, sir.
Uh, Turn on your camera. What are we going to study in this chapter? Abhinav?
Sir,
Yeah, what we are going to study in this chapter?
the laws of motion and studied like Aristotle's fallacy
Laws of motion.
or
What do you mean
inner
by laws of motion?
uh, like theorems, like
See,
truth
in the
more like.
okay, in the motion chapter, if you see, in the motion chapter, basically we have done how to describe motion. Okay, if an object is moving, what is its position, what is the displacement, how much is the time that it is taking. But in this chapter, we are going to consider the constants, okay, or the rules that the motion will follow. Under what condition, which type of motion will be available. So that we are going to see in this chapter. So first of all, we think for Aristotle, what he observed, if you throw a ball, if you throw anything, if you try to move any object, so eventually it will come to rest. So any object comes to a rest. Then Galileo performs this experiment, which is also called as his fall experiment. He performed a fall experiment, he performed a ball experiment. So let's see his fall experiment and ball experiment. What were the experiments and what he concluded out of this. So he considered an inclined plane like this. He considered a plane like this. It was steep from one side. So it was highly steep from one side. And to the other side, it went something like this. To the other side, it was not highly steep. It was very low steep, like this. So he dropped a ball from here, dropped a ball from this side. And he found out that the ball again rises to the same height. Again, the ball rises to the same height. Again, if it is dropped from here, so it rises to the same height. Okay, so this experiment was conducted on a very smooth surface. It's like it may be a very smooth wooden surface or whatever. So some smooth surfaces were taken out there. With the smooth surfaces, he observed that if the ball is released from certain height h, the ball is again able to reach the same height h. Okay, so from this thing, he concluded that if the ball is losing any energy, that is because of friction. Okay, there is some uh, contact force between the surface and the ball, because of which the ball is losing the energy. So the ball is losing energy because of the surface. So that's why there may be slight decrease in height. Otherwise, it reaches the same height from where it has been dropped off. So then he thought of an idea. And the idea was that if that means if it starts from height h, it again reaches height h, that means there is a reversal of position. It again attains the same position. Again, you can do the same experiment like this. Again, it will go the same height. Okay. So in this way, he thought that if you have an apparatus like this, okay, again with a steep, but now it is up to up to infinite. So it is up to infinitely long. And if the surface is frictionless, if
It
you
will go
drop,
forever.
yeah, it's a smooth surface. So if you drop it from certain height h, okay, so it will come from here and it will again, it will not stop, rather it will keep on moving. It will keep on moving. Okay, it will never stop. Okay. How he reached this conclusion? If you suppose this be too long, and again he makes this to certain height h. So again the ball will reach the same height. Okay. So if there is no loss of energy, the ball will reach the same height. If it is long, then also. So if it was up to infinite, so the ball would not stop. If there is no loss of energy, so it would not stop, it would keep on moving. So Galileo, he thought that no, the tendency, all the objects, they do not have a tendency to stop. Rather, they have a tendency to be in whatever state they are. Okay. So this was your Galileo's experiment. I hope everyone has understood about the Galileo's experiment.
Yes, sir.
Okay. And Galileo is also called as father of physics. Now, let's see the next one. After this came Isaac Newton, and he framed the laws of motion. Okay. So what were the laws of motion given by Isaac Newton? Let's see. So Isaac Newton gave three laws of motion. He describes motion using three laws of motion. So his laws of, if you consider his laws of motion, his first law of motion is the law of inertia. First one is law of inertia. Then you have second law of motion. It is also called as real law of motion. Then the third one is your third law of motion. Okay. It also is called as action and reaction. So this is third law of motion. So Newton gave the three laws of motion and he described all the three laws. First, in the first law, it gives us the qualitative idea of the force. It explains what is force. Then the second law of motion, it gives us the quantitative idea of force. That means measurement of the force. How much is the force? And third law, it gives us an idea that the forces always exist in pair. So we will just see each one. Let's see the first one. That is the first law of motion. Rikshit, turn on your camera.
Yes, sir. Sorry. I just
The
turned it off
law of
by mistake.
inertia, or it's also called as first law. So it gives us, it defines force. What is force? So what is a force? How can we define force?
Sir,
A push or pull of an object.
Okay, a push or pull an object on an object. And how do we define a push and pull?
sir, object at rest stays at rest. Object in motion stays in motion unless an unbalanced force is acted upon it.
So that is the first law. I'm just asking what is force. Your first law, it defines force. It gives you what is force.
Sir, it's just mass and acceleration multiplying into each other.
Okay. See, the first it states that first of all, as you said that force, it is a push or pull. Okay, so that's all correct. But for grade 9, if we say that it's just push or pull, so that doesn't suit us. So what is a force? We can say that it is an interaction between two objects. Okay. It is an interaction between two objects which tend to change the state of motion. So which tends to change the state of motion. So your first law, it defines force. Okay. What is force? It is an interaction. If two bodies are interacting with each other, where one object is trying to just wait for 1 minute, beta. Okay. So see, just thank you for waiting, everyone. So in the first law of motion, we state what is force. That is an interaction between two objects. An interaction between two objects means where one object is trying to either trying to move an object, or it is trying to stop the motion of an object, or it is either trying to change its direction. Okay. So it is an interaction between two objects when two objects are interacting with each other. Now in the first law of motion, we also state what is inertia. Okay. So as we just saw that everyone is talking of the tendency. Aristotle was also talking of the natural tendency. Galileo was also talking of natural tendency. Okay. So what is inertia? Inertia is the tendency of an object. Okay. But which type of tendency is it? So let's see. Inertia. It is the tendency of an object to be in the state of rest or of uniform motion. Okay. State of just so here we define inertia. So what's inertia then? It is the tendency of an object to be in the state of rest or of uniform motion in a straight line, and it continues unless there is a. So this is what is inertia. Every object, it wants to be in its state of rest or of uniform motion in a straight line. The object doesn't want to change its state. This situation is your inertia. Okay. Inertia of an object, it can be measured on the basis of mass it has. So inertia, it depends on what are the factors that inertia depend on. It depends on mass of an object. Just consider, suppose you have a block and you are trying to move it. Okay, if you are trying to move it, so you have to apply some force. You have to do some effort to move that object. So why you have to do an effort? It's because that the object is resisting. The object does not want to come in the state of motion. The object itself doesn't want to move. Okay, doesn't want to move, that we are saying in the terms of human expressions or feelings, but what actually means that it has an inertia, it has a resistance towards motion. Okay, and if you are if you are pushing a lighter object, you will be able to push it easily, but if you are pushing a heavy object, you will require a larger force to push it. So that means the tendency of an object to resist any change in its state of motion is dependent on the mass of that object. Okay. So what does this tendency depend upon? It depends upon the mass of object. Okay. So this point you have understood. If an object is in rest, it want to be in the state of rest. It is not going to move, or it doesn't want to move on its own. If you will try to move it, so it is going to resist it. So we will see certain experiments with the help of which we prove that inertia. And this inertia, the first type of inertia that we are talking is the inertia of rest, where we see that if an object wants to be in the state of rest, okay, so that we call as the inertia of rest. Then we have inertia of motion. So if an object is in the state of motion, it wants to be in the state of motion. If an object is in the state of rest, it wants to be in the state of rest. And the last one is inertia of direction. So inertia of rest, inertia of motion, and inertia of direction. These are the three inertias or three resistance to motion, you can call it. Now, inertia of rest means if an object is at rest, it wants to be in the state of rest. It doesn't want to move on it. That is inertia of rest. Okay. So to prove this, certain experiments are performed. We look at certain activities that happen in our everyday life. So what are the activities that we can consider here? Consider a bus that's moving. So here we consider a bus, the bus being moving on a straight road. So let's see, your bus is ready over here. I have bus for you. So in this bus, suppose the passengers are sitting, whatever passengers are sitting inside this bus, and if the bus is initially at rest, okay, so if the passengers are sitting inside it and the bus is initially at rest, the bus suddenly start moving. Okay. If the bus start moving or start accelerating in the forward direction, so all the passengers who are sitting over here, the passengers will feel a backward jerk and they will start moving. They will feel a jerk in the backward direction. Okay. So I hope everyone had an experience of this.
Yes, sir.
Yes, sir.
Okay. So if the bus suddenly starts, you will have a backward jerk. This is because of the inertia of rest. All the passengers in the bus, they were initially at rest. Other examples we like, you can see, you can do this activity at home also. Just take a glass. On this glass, put your cardboard. Take a cardboard, put over it. And on the cardboard, put a coin. Then flick the cardboard. If you flick this cardboard, so what will happen if you flick the cardboard?
The object will fall into the water or glass.
Glass. So your cardboard will move away, but the coin will not move. The coin will remain there and it will fall in the glass. So you can do this. Try out doing this activity. You will get the results. Okay. So similar reason we see when if you shake the branches of tree and the fruit starts falling. So can you explain this? Shaking of the branches and fruits falling?
So when you shake the branch of a tree, the fruit tends to remain in rest, but the branches tend to move, so the fruit falls down as it remains in the same position at rest.
Yeah. So again, over there also the fruits, their tendency is to be in the state of rest. Okay. But if we are shaking the branches, so the branches come in the state of motion and hence they experience a jerk. So all these, they are because of the inertia of rest. In the similar way, if you keep your luggage or water bottle in the bus and the bus start moving, so the bottle will fall in the backward direction. It will move in the roll down in the backward direction. This is all inertia of rest. Then the second one we see as inertia of motion. So inertia of motion is that if any object is moving, so it has a tendency to oppose any change in its state of motion. Suppose if some object is moving with speed of 20 meter per second. Okay. So the object doesn't want to stop. The object wants to continue moving with the 20 meter per second. It doesn't want to change in its velocity. So such a thing is as inertia of motion. The object is opposing its motion, so it doesn't want to stop. The object wants to move continuously. Okay. So can you give any examples for inertia of motion? Anyone can give any example of inertia of motion?
So if we take the bus example only, then when the people are moving in the bus, they tend to be in motion, but when the bus brakes, they move
Back.
backward because
Mhm.
because
Yes. So what will happen to them? Harini,
oh yes sir, yes sir.
what will happen to the passengers?
So when the bus is in motion, they also tend to be in motion with the bus, and when the bus brakes, they move forward as they tend to be in motion. But the bus stops and your legs are in contact with the bus, direct contact. So your legs tend to move back and your body moves front.
So that was a very good explanation of inertia of motion. Okay, what happens when there is a collision of a moving car or there is a collision of a moving bus? Suppose a car is moving with some speed, okay, and suddenly it collides with some barricading or whatever. So if your car collides, so your car suddenly comes in the state of rest. Okay, but your body has a tendency to move forward. So that is why your body will move in the forward direction and you are going to bash your head. On the steer wheel, you will bash your head. Okay. The passenger sitting in the backward direction, they are also going to move in the forward direction. So this is the reason why people die during collisions, as because of the inertia of motion, since the passengers were also moving with the same velocity. Okay. So when the car stops, their body has a tendency to move and hence they keep on moving in the forward direction. That is why we have those seat belts. Okay. So seat belts are there to protect us, protect our body from moving in the forward direction. Okay. So this is one of the examples of inertia of motion. You can also cite out other examples for inertia of motion. So, okay, what have you seen those? Have you seen? Okay, what will happen if you jump out of a train? Jump out of a moving train, sorry.
They're out of what?
If you jump out of a moving train or
We
moving
move
bus,
towards the direction of the train.
okay, we move towards the direction of train. Okay, and if you don't move, then you will fall forward.
Yes, sir.
So if your train is moving with suppose 90 kilometer per hour and you jump out of the train, so you also need to move with the speed of 90 kilometer per hour, then only you will be safe. Okay, you need
Yes,
to
sir.
run along with the train, and then slowly and slowly you can stop. But if you stop up suddenly, so your body has a tendency to move in the forward direction and you will fall off. Okay. So this is also your inertia of motion. Okay. Now I'm asking you one example. Let me see who can apply his knowledge. Okay. Again, suppose the bus, this situation where the bus is moving in the forward direction, in this direction. Let me mark this to be the positive direction. Okay. The bus is moving in the positive direction. Suppose if you are sitting over here and it threw a chips packet out of this. Okay. You are throwing a chips packet out of this bus. So in which direction will this chips packet move?
The backward direction of the bus.
Backward direction of the bus or forward direction?
No, forward direction.
But have you ever thrown it?
Sir, it's backwards.
Yeah,
Hmm?
so back.
Whenever you have thrown, it goes backward, right?
Yes, sir.
But as per the, if you apply the inertia of motion, so where should it go?
It should go forward, right? I guess.
Think of it. Where will it go? And let me see who can predict it correctly. And if there is anyone who can predict me the complete phenomena, what is happening?
Sir, I think the chips packet will still be in motion when it's thrown out, so it will move in the direction as the bus.
But what we observe that it goes in the backward direction.
Because we are moving with the bus and it doesn't continue the motion of the bus. Comes to the rest.
You are pretty close. You are pretty close to the explanation. Okay. See, the correct answer is this chips packet, it will move in the forward direction. It will not move in the backward direction. Okay. Due to inertia of motion, the chips packet moves in the forward direction. Okay. But we observe this chips packet to be falling in the backward direction. It doesn't move backward. If you are sitting in the bus, you will see that the chips packet is moving in the backward direction as its speed is decreasing due to air resistance. So you will feel that the chips packet is moving in the backward direction. But if a person who is outside the bus, that person is observing, so your chips packet will still be moving in the forward direction and it will not follow a backward path. Rather it will follow a path like this. It will follow a path like this. So everyone has understood this example?
Yes, sir.
Yes, sir.
Okay. Now let me tell you, give you another example, and if you can think of this, okay. Let me try to give you, and if you can apply your knowledge of this inertia of motion. So there is a hot air balloon. Okay, all of you have seen a hot air balloon.
Yes,
If
sir.
you have, okay, if you
Yes.
have not seen, still you know what's a hot air balloon. So this hot air balloon, it's rising upward with a speed of 5 meters per second, right? And as you know that the gravity acceleration due to gravity is acting in the downward direction. Okay, there is a gravitational force of gravity acting on it. So what will happen to a food packet if we drop out of it?
It will fall.
It will fall. Yeah.
Yes.
Yeah.
Yes.
Yes.
But
It
what
actually moves
about,
a little up, but then because of the speed of the hot air balloon is more, it tends to move down.
our inertia of motion? Are we not violating this inertia of motion? If you say that it will fall,
So the gravitational pull is acting.
Gravity is more, right?
Yeah.
so still are we not violating inertia of motion? Think of it. If it
No,
will
sir,
fall,
because it's acting on the backward direction as well, right? So it will go down.
see. So today I have given you good examples. I think you people have not seen such examples ever.
Yes, sir.
Okay. So see, your correct answer is that this will not fall in the fall down. Rather, it will rise up. The food packet, it will rise up to a certain height so that its velocity now becomes 0 and then
Then
it
it
will
will
start
drop.
falling. Then it will drop. Okay.
Wait,
So we
Harini said that though.
Yeah.
so
Sir, Harini said that though, like 5 seconds ago. She said it will go a bit up and go down.
It will go a bit up. So how much time will it take? That we can calculate from the acceleration. As we know that the acceleration due to gravity is 9.8 meter per second square. Okay. At the final
why will
velocity,
it go up?
No,
because
because
of
it will
inertia of,
have to become 0 to drop down again, right?
yeah,
We are not
because of inertia
throwing
of
the
motion. Just like the food packet. Just like the food packet. Just like the food packet went in the forward direction because of inertia of motion. In the same way, because of the inertia of motion, this food packet will move in the upward direction. Okay. So when the food packet is dropped out of air, it has a velocity of 5 meters per second upward. Are you getting?
Sir, but we are not throwing it like a vertically project. No, like we are not vertically projecting it, right, sir?
You are not projecting it, but you are carrying it along with you. You are carrying it along with the balloon. So it has the velocity of 5 meters per second upward direction.
So
See the,
even if you throw a stone or any heavy object also it will work?
yeah, any object. Even if you're carrying any object along with the balloon, so it will be the same thing.
How stones
But
are like
hmm,
how stones are like literally how does it go up with us and then fall down? We are like if it has to become 0, we have to vertically project it, like throw it up and then it
okay.
has to
So
return.
okay. So this you agree that you have to throw it up? All of you
Yes,
agree? Okay. So what is the velocity of the balloon when it is what is the velocity of this packet when it is dropped out of the balloon? Is it 0
uh,
or is it 5 meters per second upward?
So 5 meters per second upward.
Okay, it is 5 meters per second upward. So can I say that the food packet has been projected upward with a speed of 5 meters per second?
Yes.
Are you getting my point?
Yes, sir.
Okay, think of it. Think of it. Okay, my all questions and everything, they are not that too easy. Think of it, you will get it. This
So the
example
weight
of
of
chips
the
packet
object also
also.
matters, right?
Yeah?
So the weight of the object also matters then.
No, it will not matter. That we will see in the gravitation chapter that the weight doesn't matter.
Okay, sir.
Okay, in the chapter gravitation, we will see that the weight of the object doesn't matter.
Okay, sir.
Okay. Any other doubt? I hope this is clear to everyone. You need some thinking before it. Yes, shall we move ahead now? Okay, so I'm moving ahead. I think that there is no doubt on this topic. All right. So let's see the next one. That's inertia of direction. Next one is inertia of direction. So what is the inertia of direction? It is the tendency of an object to move in a straight line. The tendency of an object to maintain its direction of motion. This is the inertia of direction. Okay. If you want any object to turn, so it will oppose that turn. And if anything is opposing it, so you have to do it by force. Okay. If your parents are saying that you have to study and you are opposing it, so they have to apply some force, right? So whenever you have opposition, to oppose that opposition, there to overcome that opposition, you must apply some force. So that is the word force came into the common language. You have been forced to do this. Okay, as you are resisting it, so you have been forced to do this. So in the similar way, we have inertia of direction. If an object is moving in a straight line or in a straight path, let's say here we have a ball which is moving along this direction. Okay. So it will continue to move along the same direction unless any force is acting on it. Its tendency is to move in the same direction. It doesn't want to change its direction, and it will not. Okay. So about all this, we are studying now. Okay. But we as small kids were all aware of such laws. We were all aware of such things. Let's see. If you see at your home any small kid, okay, the kid may be 2 years, the kid may be 3 years, maybe 6 months, or maybe 1 year. Okay, let's see his logic. And if he is able to apply this inertia, okay, he has not studied, the child has not studied anywhere inertia, but still he applies inertia. Okay, so what, consider my example. Okay, suppose this is your room or coordinate of the, I have described a room as a coordinate. The child keeps a toy over here. Okay. See, the child keeps a toy over here, goes somewhere and again returns back. Okay. So where he will search for the toy?
In the same place.
In the same place. Why at the same place?
Because he left it there.
Because he left there and he knows that it will remain there. Okay. It will remain there in its state of rest. It will not move on its own. Okay. So this is what we studied as the inertia of rest. That it will remain there. It will not move on its own. Okay. What if he doesn't find the ball over there? If he doesn't find the ball over there or toy over there, so he will go ask someone that where is my toy? Where is my toy? You have kept it. Why? Because he knows that it cannot move on its own. There must be someone who has moved it. Right? So even as a toy, as small kids, they are all aware. We are all aware of such laws of motion, but we do not know their studies. Okay, suppose the boy, suppose you are standing over at some place near the boy. Okay, let's say you are standing over here and you tell the boy that come on, throw the ball to me. So the boy will throw the ball towards you. The boy will throw the ball along the same straight line. Isn't it? Or the boy will throw somewhere else. He will throw along the same straight line as he is aware that inertia of direction. When he is throwing along this direction, so the ball will travel along the same direction. Okay, so all these are your inertias. Inertia of motion, inertia of direction, and inertia of rest. What you have studied in your books, that if you try a luggage on your, let's say a bus taking a circular turn. Okay. So suppose there is a circular turn on which your bus is taking a circular turn. Suppose your bus is moving over here, it's taking a circular turn. Okay. So at this point, if you observe at this point, the bus has a tendency to move along this direction, along the tangential direction. if you look at this point, the bus has a tendency to move along this tangential direction. Okay. There is a change of direction of motion of the bus, and therefore the passengers who are sitting in the bus, those passengers, they will feel an outward jerk. The passengers will feel an outward force. They will feel that someone is pushing them in the outward direction. Okay. So why they will feel a force in the outward direction? It is because of the change of direction. They want to move in the straight line. The passengers, they have a tendency to move in the straight line. Okay. So I hope everyone has understood about all these inertias: inertia of rest, inertia of motion, and inertia of direction.
Yes, sir.
Wait, sir, can you just explain the circle one again once more?
Okay, circle one. Suppose your bus takes a turn. Okay, let me mark it like this. Suppose the bus takes your turn. So at this point, the bus has a direction of motion along the tangent. Okay. Now, if it is at this point, so the bus has changed its direction. Okay. There is a change of direction of motion, and therefore passengers have a tendency to move along this line. They have a tendency to move along this path. Passengers want to move along this path, but the bus is turning them along this path. Bus is taking them a turn. Okay, so the passengers will oppose their turn, and hence they will to oppose it, they will move in the outward direction. In the similar way, if you keep a luggage on the bus, and just if the bus is taking a turn, so the luggage will fall in the outward direction.
Okay, sir.
Abhinav, any doubts? You have turned off your camera.
I
Abhinav,
understood,
hello?
sir.
Okay, just everyone keep your cameras on. Do not turn it off. Siddhisri, are you there? Siddhisri, if you are able to talk, so just speak up or message in the chat section. Or within a minute, I'll be telling in the group, informing where you are. Okay. So any doubts regarding all these inertia and laws of motion?
No, sir.
Okay. Yes. About the Aristotle fallacy. So why the Aristotle fallacy? As initially, whatever Aristotle told was a natural phenomena he observed, and from that it was proved wrong by the Newton's first law of motion and Galileo's inertia and the fall experiment. Okay. So okay, so all of you now, this is with this. Now we come to the statement of the first law of motion. This was all about inertia. What are the different types of inertia? Before ending up, we put up the statement of the first law of motion. Okay. So the first law of motion, it states that Okay, can anyone tell the statement of the first law of motion?
An object tends to stay at rest unless compelled by an external force.
Okay, so I can say that every body
Wait, sir,
continue.
is it not easier to say
Yeah.
an object will not move unless and until an external force acts upon it?
Okay, you can say object. Okay, but we say object generally. In the case of physics, we say body. Everything is a body. Every object is a body. In the state, you can say object. There is no problem. Unless acted upon by an external unbalanced force. So what are balanced forces and what are unbalanced forces?
Balanced forces are the ones that when it is applied, the net force is zero. That means the object stays stationary, and unbalanced lead to motion in an object.
Okay, anyone else would like to say what are balanced forces and what are unbalanced forces?
Balanced force or net force is zero, so it need not be in rest.
Okay. We are not talking of whether it is in rest or in the state of
And
motion.
okay.
I will show you the situations when the object is still moving, but the forces are zero. Okay. So here we have two objects, and let me show you that. Let's say suppose here some force is acting on this. Here another force is acting along the same line, but in the opposite direction. So this is a 3 Newton force. This is a 3 Newton force. Okay. So are these forces balanced? Are these forces balanced or unbalanced?
So the first one is balanced.
Balanced.
Okay. In the first one, the forces are balanced. And if you have here 3 Newton, if you have here 2 Newton, so what about it?
So unbalanced.
Unbalanced. Okay. What can you say about this? Again, both the forces being equal. Are these balanced or unbalanced?
Balanced.
They are balanced. Okay. Let's see. Okay, what about this? Can you say that the forces are balanced? Yes. For which can we say for this one are the forces balanced?
Yes, sir.
Yes, sir.
On the last one.
So for the last one, we can't say it's balanced.
Okay, last one is unbalanced. Okay. Consider an object and someone is pulling along this direction, someone is pulling along this direction. So don't you think that it is going to move along this diagonal?
Yes, sir.
So it's a unbalanced. Okay, this is a balanced. This one is also unbalanced. Right? Okay, what about this? Just this is the last one, which you can say whether it is balanced or unbalanced. We have 3 Newton here, 3 Newton here, and 3 Newton. So are these forces balanced or unbalanced? Yes, come on. What about this? Are these balanced or unbalanced?
Sir, it's unbalanced.
It's unbalanced. Okay. So thank you everyone. Bye everyone. Good night.
Thank you, sir.
Bye.
Bye, sir.
Bye.